Okay, when we have the endo-reversible engine, this concept, we can use this concept to discuss several special engines. Trembedo-Novick engine, Cousin-Elber engine, and Stefan Boltzmann engine, 3 very special engines. Firstly is Trembedo-Novick engine. This engine is very simple, very similar to the Carnot engine, but more heat resistance from T1 to T3. But from T3 to T2 is still a reversible engine. So very special. Only at a T3 the heat resource. But here we assuming the heat transfer to Trembedo-Novick engine is still QH. To the low temperature reservoir is still QL. The efficiency certainly easy to be calculated is it N equals 1 minus QL over QH. Here is this Trembedo-Novick engine, the efficiency, eta N. Now let's calculate the power and efficiency of CN engine, Trembedo engine. According to the assuming conditions, we know from the heat transfer, we can calculate the QH equals G times T1 minus T3. From this QH equals G times T1 minus T3, just the temperature difference. Also, endo-reversible engine has no entropy generation in the engine because we is still assuming the engine is still reversible. So there is no generation in entropy generation. So we still can get QH over T3 equals QL over T2. But remember, here is T3, is not T1. Finally, the work production is W equals eta N QH equals G T1 minus T3 times eta N. Also equals G T1 minus T3 times 1 minus T2 over T3. Here is the work. Finally, the CN engine produced work. From here, we can find this work always relationship with T3. Also, we can eliminate the T3. We obtained W work equals G times T1 minus T2 over 1 minus eta N times eta N. Obtained this equation. From this equation, it indicates when the efficiency of the endo-reversible engine is very big, it is not sure the work export is also big. It cannot be sure. For calculate the work, maximum work, we can do partial W partial eta N, and all it is 0. Finally, we can obtain the optimal efficiency is eta N optimal equals 1 minus root T2 over T1. You can find from this equation, it is not same as the Carnot efficiency. Carnot efficiency is 1 minus T2 over T1. But here is 1 minus root T2 minus T1. Root T2 over T1 is not the same as the Carnot efficiency. Okay, we can do draw some picture, draw some curves like this. The optimal heat source temperature is T3 optimal equals root T1 times T2. W maximum is G times root T1 minus root T2 the power second. We can find if we use the Wn as the vertical axis, T3 as the horizontal axis, we can find that the work output, there is a very special the curves. There is a very good the maximum, the Wn maximum. There is a point is very good. In the previous discussions, the irreversibility of system is considered to be generated by out conditions. Engine internal is still reversible. Here is just, you can find just at a resistance in the system, in the engine, the output work, there is very big the change. Very big the change. It's not different with the Carnot engine. Okay, next example is Cousin-Elbern engine. In this condition, two middle heat sources was added in the temperature T3 and T4. The Cousin lost the engine only add a resistance in here, but Cousin-Elbern engine add another resistance in the low temperature and the engine. So make another source T4. From the heat transfer, very easy to calculate the heat transfer quantity. Q1 is G1 times T1 minus T3. Q2 equals G2 times T4 minus T2 because the engine internal is still reversible. So we have Q1 over T3 equals Q2 over T4. Please remember, here is T3, T4 is not T1, T2. No entropy generation in the engine because the engine is still reversible. So we obtained G1 times T2 minus T3 over T3 equals G2 times T4 minus T2 over T4. Obtain this equation. Also, due to the internal engine is still reversible, so we can calculate the efficiency of the engine is 1 minus T4 over T3. Together, previous equations, we can obtain the Q1 can be calculated. The Q1 equals eta C minus it over 1 minus it times 1 over G1 plus 1 over G2 times T1. Because this equation is from the Cousin engine, there is some resistance, heat resistance. The relationship between Q1 and the engine efficiency we obtained. The vertical axis is Q1 over G T1. G just the total resistance. We can add G is 1 over G equals 1 over G1 plus 1 over G2. We can add. So here G is a symbol to express the resistance. The horizontal axis is the engine efficiency. We can find eta C is the Carnot cycle efficiency. You can find for any Carnot efficiency, for example, eta C is equals 0.8. The bigger engine efficiency, the Q1 over GT1 decrease is different. Also, for CA engine, based on the relationship with W equals it times Q1, finally we can obtain the work export. So W equals eta C is Carnot efficiency, minus eta is this system efficiency. So obtained times it T1 over 1 minus it times G1 over G1, 1 over G1 plus 1 over G2. Here we can order 1 over G equals 1 over G1 plus 1 over G2. From this equation, we can draw the picture like this. For any Carnot efficiency, we can obtain one curve, the work change the efficiency of the engine. We can find for any Carnot efficiency, the work, there is a point, work export is maximum. So any Carnot efficiency, we obtain the one curve. In this curve, there is a one point, the work export is biggest. So to obtain the maximum work, the efficiency of engine should be chosen. Order parcel W, parcel 8. We order it is 0. Easy to get the equation like this. Partial differential. So from this equation, we easy to obtain the optimal efficiency. To obtain the maximum work is it equals 1 minus root T2 over T1. Also, we can find the efficiency is not Carnot efficiency. So CA engine and Carnot engine is different. We can do some comparison about the efficiency. Cousin Airborne engine and Carnot engine. From this picture, the vertical is engine efficiency. The horizontal axis is T2 minus T1 over T1. T2 over T1. The straight line is Carnot efficiency. Curve line is this engine efficiency. You can find at any point this engine the efficiency always smaller than Carnot engine efficiency. Okay, the third very special engine is Stefan-Boltzmann engine. Stefan-Boltzmann engine is similar CA engine, but we think the heat transfer from hot source to engine and from the engine to the environment is completed by radiation. Then the engine is called Stefan-Boltzmann engine. We know Boltzmann engine, the heat transfer only by radiation. So Q1 equals G1 times T1 power force minus T3 power force. Q2 equals G2 T4 power force minus T2 power force by radiation. Same way, we assume an endo-reversible engine because we can think this part is still reversible. At the same thing, we can do the same thing as the last page. Eliminate T3 and T4 relationship, the heat and work as follows. SB engine, we can obtain Q1 is very long the relationship. W also we can calculate. Q1 and W we can calculate, obtain the calculation equation. At the same time, it can be found the efficiency has some influence on the export work. Certainly, efficiency, there is some influence on the export work. We should choose the efficiency. It is not best when the efficiency is biggest. We should select the efficiency. It should have an optimal quantity. Even it equals eta C, maybe it's not good. We can find when it equals eta C, the export, the work is 0, no useful. Also, we can draw some picture for Q1 and it, W and it, delta S and it diagram. We can find that the picture may be similar like the Kaizen engine. Very similar. We can find as the eta C, it reach the eta C, the entropy decrease, entropy change decrease to zero. So we should select the engine, the efficiency. It's not the bigger efficiency, the better. It's not. Also, for Stephen Boltzmann engine, we can do some diagram, draw the diagram. The vertical is engine efficiency. The horizontal axis is T2 over T1. We can find when G1 small than G2 is like an engine like this. It is similar Kaizen engine. When G1 equals G2 is like this line, is this line. When G1 larger than G2 is like this line. So from this picture, from this diagram, we can do some analysis for Stephen Boltzmann's engine. Thank you.